Okay, this is Thursday, 4/26, and today we have notes on determinants and areas from section 35.3. So, section 35.3, and it is page 509. Okay, I'm waiting for you guys to open your books. So today our learning targets are to work with matrices to represent real-world situations such as determining the acreage of a lot, and you can do this from your car, and we're going to interpret absolute value of determinants as areas. So basically, when I say a surveyor can get out of a car, and they have these little devices that it's kind of like a laser. It shoots you can shoot, find an area, and you can shoot it out, and it'll tell you the distance. And it can also do this one. So you yourself is like a 0, 0. Okay, you want to think of yourself as a 0, 0. So as long as one of the points is 0, 0, you can find the area of this triangle by using determinants. Now they want you to do a bunch of stuff in this little book here, but since I'm not here, I think it'll be hard for me to explain to you because you'll probably have questions. So I'm just going to give you the actual formula for the area using determinants. Okay? So the area, let's write it really big here, is going to all be 1/2. Most areas always start with 1/2 of triangles, right? 1/2 base times height. So in this case, we're going to start with the 1/2, and then it's going to be times the determinant of a 2x2 matrix. Now this 2x2 matrix is going to be with the 2 ordered pairs that are in there other than the 0, 0. So you don't count the 0, 0, you count the other 2. So you do the first one, which is point A, as TU, and you write this as a column. So that's column 1. Now the second order pair, which is order pair B, is RS, and you write that as column 2. Now, to simplify this, you will change these to parentheses when you start cross multiplying. So T times S, this is how we find a determinant, minus R times U, and whatever these numbers are, you would actually know this as a single value right here. This would be a single value. And we do, now in determinants, I always said this is not absolute values, but I do want you, in terms of area, we can't really have a negative area. We are going to take the absolute value of this. So if this is negative, we are going to make this positive. So I'm going to put a little note there. This should be a positive value. And whatever that is, you're going to take 1/2 of it, and you will have your area. Pretty easy. So on the next page, on page 510, we have this big old problem, and it's a triangular piece of property, and they divided it into lot 1 and lot 2. Let's try to get this thing straight here for you. It's a bit harder to do this with the springboard here. Do I have it all in there yet? There we go. Is that all in there? There. All right, so you own both these pieces of property. You own triangle 1. And you know what? Let's go ahead and highlight this area here. So lot 1, this is lot 1. Lot runs along East Avenue, and then there's a fence right here. And then we have, I hope this is a highlighter, lot 2, which runs along Division Street. And there's a fence between the 2 lots. Okay, so number 2 says calculate the square footage of lot 1 and lot 2. So lot 1, if you notice, the 2 ordered pairs, okay, you got, see how you got the 0, 0? The 2 ordered pairs are 300, 0 and 300, 100. Those are the 2 ordered pairs that, with the 0, 0, form this orange triangle. So lot 1, I'm going to move this down just a little bit. So lot 1 area, I'm going to put area of lot 1 is equal to 1/2. So we're going to go with C here, we're going to go 300, 0 And then point A is 300, 100. Depending on which way you write these ordered pairs, you might get a negative, but that's okay because we're going to take a positive value no matter what. So when you do this work, we're going to get 300 times 100. So let's see, 300 times 100. 3 times 1 is 3 with 4 zeros. 1, 2, 3, 4. Minus 0. So it's basically 1/2 of 30,000, which is 15,000. And that, I believe, is square feet, right? Is it in feet? Yeah, it says up here on the top, it says all these distances are measured in feet. So this is 15,000 square feet. That's lot 1. Now we're going to find lot 2. Now lot 2 is much larger, so this answer should be bigger. I think I'm going to do this work up here because I'm already out of room. I wrote too big. So lot 2, area of lot 2. You still can't see this. Area of lot 2 is 1/2. Now the ordered pairs that we're going to use for the yellow triangle are 300 and 100. So I'll circle that again. I'll do this one in blue. So 300, 100, and 400, 400. Those are the other two that are along with 0, 0. So this is going to be 300, 100, and 400, 400. So if you're doing the work for this, 3 times 4 is 12 with 4 zeros, minus 1 times 4, which is 4 with 4 zeros. So it's 1/2 of 120,000 minus 40,000 for 80,000. 1/2 of 80,000 is 40,000 square feet. Okay, so that's lot 2 and lot 1. Any questions? I wish I was there to answer them if there are. Ask a neighbor real quick. I'll give you a second. Okay, so number 3, make sense of the problems. Verify the determinant you wrote in item 2 is correct by using it to check the values you calculated in item 2. I think I'm good. Let's just go. Check your understanding. Using determinants, calculate the areas of triangle dots whose vertices are given. So let's just do one of these. Just pick one. I don't care. Let's pick B. Do 4B right here. So if you're doing 4B, you would go area is 1/2. So you remember, see that 0, 0? So I don't care which one you write first. We'll go negative 200, 300, and 40, 50. And then that would be 1/2. Negative 200 times 6. So negative 2 times 5 is negative 10. Now count your zeros. 1, 2, 3. 1, 2, 3. Minus 3 times 4 is 12 with 1, 2, 3 zeros. And this is negative 10,000 and negative 10,000. This is negative 12,000, so it's negative 22,000. But because it's an area, we're going to make that a positive. So 1/2 of 22,000 is 11,000 feet squared. Now number 5, it says sometimes lots are sometimes given in acres instead of square feet. Convert your answers from item 4 to acres. So if we were converting this to acres, do you know how to do that? It says right here, 1 acre is 43,560 feet. Let's take, for example, let's do the one from up here. This one from 40,000 square feet. So we're going to go over here. If I wanted to convert this to acres, I would take my 40,000, and I'd set it equal to 43,560 feet squared, and that's equivalent to 1 acre. And we're trying to figure out how many acres this one is. I'm going to set some kind of proportion up like this. So acres on the bottom, square feet on the top, cross multiply. All right, give me a second. 4,560 feet squared. X equals 40,000. And then you want to divide. And if you punch this in your calculator, I'll give you a second. you get about 0.8035 acres. So this one right here, this lot 2, is just under an acre, about 0.8 acres. And that's how you determine acreage of a lot. Are you taking chapter 7 test?
Yeah, I don't think that's
That's the big 100-point test, right? Yeah.
Can I have this, please?
Yeah.
Thank you.
Here it is.
Thank
You got
you.
All right. Let's go down here to number 7. So go to number 7 on page 511. So not all triangular lots will have a vertex at the origin. Okay, so what would you do? Basically, you would have to do something we did in the last section. You would have to shift everything. Like pick one of these. I don't care which one. Maybe the lowest one here. I would have to shift all of this over here. So basically, if I wrote all these ordered pairs, if I wrote A, TU, and then B, RS, and then C, VW, I'm just going in order ABC, and I wanted to shift this, I would want to make everything go T left and U left to get this point right here to the origin. I need to get one of these points to the origin. It doesn't matter which one. So if I choose A, to move A, shift it left and down, basically. You have to shift it left and down. I can make this an origin, and then everything, this whole triangle would just translate over. Okay? So to do that, I need to move everything T left and U down. So if I want to move everything T left on the top, I would do this. Negative T, negative T, negative T. I'm shifting everything T left. All 3 ordered pairs. And I'm also going to shift everything U down. The down goes on the bottom because that's the Y. The left goes on the top. So I'm going to go negative U, negative U, negative U. So my new ordered pairs would be T minus T, which would be 0, R minus T, and V minus T. And then on the bottom, you have U minus U, which is 0, S minus U, and W minus U. And this would be our new triangle. So our new triangle would have the points 0, 0, up here R minus T, S minus U. That would be B. It would be A prime, B prime. And then you'd have another one over here, V minus T and W minus U. Those are your new ordered pairs of this triangle. So to find the area of it then, of A prime, B prime, C prime, you would find 1/2 of R minus T and S minus U. That's the first order pair. The second order pair is V minus T and W minus U. And then you would cross multiply these. This, take half of it. And that's pretty much what you have to do. So we're going to do one with real numbers on the next page. So we're going to go to page 512. We're on page 512. And we're doing some practice problems. So this is, what is this? 1, 2, 3, 4. This is a 5-sided figure. So we're going to use the method we just did to find the area of the polygon figure. Actually, we don't even have to use that method. This one's easier. So we're going to divide this into 3 triangles. I don't care how you divide it, but it needs to be into triangles. So you can't go here because that's not a triangle, but if you go here, that's a triangle. We're going to call this, we'll call it lot 1. And then this one is going to be lot 2. And lot 3. Do you need to take a test?
I have a few questions before the test.
I got to do this video. So lot 1, so we're going to find the area of lot 1. So the area of lot 1 over here would be 1/2 of 4, 0 and 6, 2. which would be 8 minus 0, which is 1/2 of 8, which is 4. So the area of lot 1 is 4. Now we're going to add that to area of lot 2. Now the area of lot 2 is 1/2. Now this time we're using order pairs 6, 2, and 5, 6. You see that? 0, 0, 6, 2, 5, 6. So the first order pair is 6, 2. And the second order pair is 5, 6. So we have 6, 2, and 5, 6. Right here, 6, 2, 5, 6. So this is 36 minus 10, which is 26 times 1/2, which is 13. And we're going to add 4, and we're going to add 13 together. So far the area of this thing is 17. And then the area of lot 3, so we're going to go up here to lot 3. We have 0, 0, we have 5, 6, and 2, 5. So we have 5, 6, and 2, 5. We have 5, 6, and 2, 5 for the third one. 5, 6, and 2, 5, which is 25 minus 12, which is 13. Oops, that's parentheses. Times 1/2, which is about, what, 6.5? So if you add 4, 13, and 6.5, you get 23.5. So this answer would be 23.5 if it was in feet, square feet. But since it's not in feet, we'll go units squared. All right, so for this one right here, I think we're good. I think you guys can get started with the homework. Just so you guys know, when you look at your homework on page 514, you see this problem right here? I do kind of want to just help you with 12 a little bit. I'm going to show you 12, just get you started on 12. 110 is like up here. We'll call that point A. 6, 2 is down here. We'll call that B. 1, negative 5 is here. And negative 3, 5 is here. We'll call that D. So this is basically what your picture looks like. But notice none of these are at 0. We really need one of them to be 0. So you have to choose which one you want to go. So I'm going to get this set up down here. We have 1, 10, 6, 2, 1, negative 5, and negative 3, 5. Just by the way, I don't know which one I would think I'd probably move D. This one right here, to me it would be closer. Like I'd move everything to the right. Not only would that do that, but it'd make everything positive. Well, not everything, not this one. Well, I guess I could move this one up. If I move this one up, everything is going to be positive above. I would either move A or D or C. Let's just say we're going to move D. So point D is negative 3, 5. It's this one right here. So if I need to move that to the origin, I need to move this negative 3 to 0. So I need to move this negative 3 to 0. So what I would do is I would add 3 to all 4 of the top numbers. And then the 5 is right here. I need to move this one down 5 to get it to be 0, 0. So again, this is circled. I would subtract 5 from all of these. Now what that does, 1 plus 3 is 4. 6 plus 3 is 9. 1 plus 3 is 4. But negative 3 plus 3 is 0. There's that 0, 0. 10 minus 5 is 5. 2 minus 5 is negative 3. Negative 5 and negative 5 is negative 10. But 5 minus 5 is 0. There's your origin. So what you would need to do is regraph this. This is going to be point D now. And you have 4, 5, which is A prime, D prime. 9, negative 3, 4, 5, 6, 7, 8, 9, down 3. This is going to be B prime. And 4, negative 10 is like way down here. We're going to call that C prime. And you have the same picture, but it's been moved. It's been moved. And then you would just divide this up into 2 triangles. And then find the area of this one and find the area of that one. Hopefully that helps you set up number 12. The rest of them I think are pretty easy. And that's it for the notes.